When we perform a reflection, we take a point and we reflect it across a line. If it's on the line, the point doesn't move. If it if it does move, it's going to be perpendicular to our line. It's going to be the same distance from the line as the line is from its image. We call the original point the pre-image, and we call our reflected point the image. You'll notice that happens quite a bit. If we take a look at example 1, what we're going to do is we're going to play a game of billiards where you have to bounce it off a certain size. It kind of looks like a pool table, but billiards is a little bit different. We're going to take our ball and we're going to put it into the hole at B, but we have to reflect it across A, this line A. So here's what we do. We take B and we treat A as the line of reflection, and I reflect B across A. I've done that in the picture down here. So I took B, I reflected across B prime. Then I connect a point for my cue ball, or my ball, straight to B prime. Where it hits, that point is going to be where we want to place the ball. So it will follow that path, hit the pocket, and go into B. And there I connected the points for us. Now, if we take a look at example 3, it kind of looks very similar, doesn't it? The only difference is instead of a vertical line, we're going to reflect it across a horizontal line. So I'm going to take C, I'm going to move it 1 down to get to my line of reflection. I'm going to go 1 more. And here's C primed. B, if I count, B right now is up 2. Well, if I go down 3, I have to go down 3 more then. And there we have B primed. And then A is 1 more, but it's in line with C, isn't it? So here's A primed. And then D is up, and I'm going to count here. It's up 1, 2, 3, so I'm going to go down 1, 2, 3. I'm going to be at -5 there. Now if I connect my points in order, then I have my new image, and it is congruent to your original image. There are 3 special reflections we should be aware of. They all occur in the coordinate plane. That is when you reflect something over the x-axis, or the y-axis, or the line y equals x. We'll start here with the x-axis. When you reflect something over the x-axis, notice what happens. It moves vertically. So in other words, we call this arrow notation from x to y, gives us x to -y. So we're just going to move it down 1. In this case, I moved it down 1. But my y just becomes opposite. When reflected over the x-axis, I said that wrong. When you reflect it over the y-axis, your points become the opposite, so x becomes opposite. So if I take a look at example 4, I'm given this quadrilateral and its image. And I want to describe the transformation using coordinate notation. Well, notice what happens here. Look at point A. The x's stayed the same and the y's became opposite. At point B, the x's became the same, the y's became opposite. So what happens when the x's stay the same and the y's become opposite? Well, we're going to say that's a reflection over the x-axis. And if we want to put this in coordinate notation, we're going to say, just like it says in the box above, xy becomes x and the opposite of y. Now, if we take a look at example 5, I want to graph the quadrilateral ABCD, which I've already done for you. And only this time, I want to do the reflection and the y-axis. So I'm going to do the coordinates first. I'm going to start here, and I'm going to say, okay, A starts at 1, 1. Well, if I do a reflection over the x-axis, it'll be at negative 1, 1. Negative 1, positive 1. If I look at the coordinate of B, right now it's over 1, 2, 3, and up 1, 2. So it's 3, 2. So the new coordinate is going to be negative 3, positive 2. If I look at the coordinate of C, let's go 1, 2, 3, 4, negative 1. So C right now is at 4, negative 1. Well, that's going to become negative 4, negative 1. And finally, point D, if I look at it, it's over 1, 2, and down 1, 2, 3. So right now it's 2 and negative 3. I don't know why I wrote an extra parentheses there. I'll get rid of that in a second. And that becomes negative 2 and negative 3. Now let's plot those points. So negative 1, 1, we're already plotted. Let's plot negative 3, 2. Let's plot negative 4, negative 1. And let's plot negative 2, negative 3. And then we have our two images. Here's the third example we talked about. If you reflect it over the line y equals x, well, think algebraically. Y becomes x. That's exactly what's going on. So xy, you just flip the order around and it becomes yx. And so we'll do that same thing here. We'll do it kind of like we did the previous problem. That is, we will write the coordinates out first, and then we'll graph them. And something kind of interesting happens on the first one, doesn't it, if you notice. So A is at 1, 1. So A prime, you flip them around, it's the same thing because they're exactly the same to begin with. B, which is at 3, 2, that becomes 2, 3. C, which is at 4, negative 1, we don't switch the signs at all in this one, becomes negative 1 and 4. And D, which was at 2, negative 3, that becomes D primed is at negative 3 and 2. So we don't change anything with A, and it's A primed. B is at 2 and 3. Should say B primed. C primed is at negative 1 and 4. Except I can't count. That was 3. That's why it looks so weird. Let me fix that right now. And there's C primed. And then D primed is at negative 3 and up 2. And there's your image after you reflect it over the line y equals x. Notice on the bottom of your study guide, I have made a chart for you to help you keep those three intact there.